Welcome to the second video for section 2.2 and the last video for the first half of the Pre-Calc 11 Trigonometry unit. So before you watch this video, you should have watched all the videos for section 2.1, as well as the first video for section 2.2 and the grade 10 Trig review. So it's a whole bunch of stuff that kind of leads up to this. This particular video is going to be kind of bringing together everything else we've done throughout the unit. So if you haven't seen any of the other stuff, you're going to be pretty lost. So definitely make sure you go back and check everything else out before you proceed. So just before we dive too far into this, just as a refresher, something that we're going to need is our special triangles. So I'm just going to sketch those out real quick. Always a good idea to put them at the top of pretty much any page in this unit because you never know when you're going to need them. So our first triangle was our 30, 60, 90 triangle. And then remember for side lengths, the smallest side length in that triangle was 1, so it's across from the 30. The biggest was the hypotenuse, which is 2. And then we've got the root 3 for the other side. Our other special triangle was the 45-45 triangle, and so if we sketch that one out, both of our non-right angles are 45 degrees, and then our other sides are 1, 1, and root 2. All right, so in this question, or in this unit, you might be asked something along the lines of determine the exact value, so this should already be bringing back some bells, the exact value of sine of 135 degrees. So we saw something like this when we were doing our exact value stuff in the last video with the special triangles, but 135 isn't in any of our special triangles, right? It's too big. So let's try sketching this out first, just to kind of get a sense of what's going on. So we got a quick sketch. We got our initial arm, because we're going to be drawing this in standard position. We've got our terminal arm. 135 is over here, right? That one's exactly between 90 and 180. And we've got our arrow. And so here's the thing. Yes, this is 135 degrees, but we're not actually going to work with 135 because there's something that we learned earlier in the unit that can help us. So quick reminder for you, an angle and its reference angle, so we're bringing back reference angles, are going to have the same trig ratios except for one thing. So remember, it's the exact same trig ratios for any angle that has the same reference angle. The only difference is maybe the sign, maybe the plus or the minus. So if we want to do sine of 135, the first thing we actually want to do is to figure out what the reference angle is. So remember, the reference angle is always just the angle between your terminal arm and the closest part of the x-axis. So we're going down to here. So this is my reference angle, theta r. This is the thing I want. So to get your reference angle, remember you're just going to subtract. So we're going from 145 to 180. So I'm just going to subtract those two angles. Oh, sorry, 135. Getting a little ahead of myself. So 180 minus 135 is going to get you 45 degrees. So that is our reference angle. And that is something that does pop up in our special triangles. So now we're going to determine what sine of 45 is using those special triangles. So if you look at your 45-45 triangle, because 45 is the angle we're working with, your sine ratio, your opposite over your hypotenuse, is just going to be 1 over root 2, right? So that just comes from here. If we're doing with that, we got opposite, we got hypotenuse. But that's sine of 45. I didn't ask you for sine of 45. I asked you for sine of 135. So what's the difference? Well, like we said, it's the plus or the minus bit. So is this going to be positive 1 over root 2 or is it going to be negative 1 over root 2? So what have we seen in this chapter that related positive and negative trig ratios? So if you think back, a couple of videos, because I did say this was going to draw together a lot of different things, we saw a different memory tool, not SOHCAHTOA, but something new that helped us to remember positives and negatives. And that was your ASTC. So remember, we got ASTC, and this tells you what's positive. So remember, whatever letter is here, whether it's cosine or all or sine or tangent, whatever letter you land on is the one that's positive. So in this case, if we're doing 135, that means we're in quadrant 2. And so in quadrant 2, we're working with sine, right? So we're doing sine 135. In quadrant 2, sine is positive. And so in that case, we're going to combine those two bits of information, and we're going to say that sine of 135 is positive from this thing, 1 over root 2 from this thing. And so there's our answer for this question. So let's try a different one. So we're going to find the exact value of tangent of 300. So if we sketch that quickly, right, 300 is in quadrant 4. And this doesn't have to be an amazing sketch, right, because that's not the goal of the question. So don't sweat too much making it match nicely. It's somewhere over here, maybe something like this. So this is my 300 degrees. My reference angle is this angle here. And so to calculate that, right, it connects 300 degrees and 360 degrees. So we're just going to do 360 minus 300. And so our reference angle is 60. So instead of tangent of 300, we're going to start by doing tangent of 60. And we're going to use that as sort of a guideline. So tangent of 60, if you go back to your special triangle up at the top of this, so tangent of 60 is opposite over adjacent, so that's my opposite, that's my adjacent. So tangent of 60 is root 3 over 1. Or just root 3. And so now if we think ASTC, we're in quadrant 4, and in quadrant 4, cosine is positive. But if cosine is positive, that means tangent is negative. And so tangent of 300 is going to be negative, right, which just comes from there, root 3, which just came from our reference angle. And there we are. So that is how we do some exact values. So I'm just going to give you a few of these to try on your own. It's just good practice. So do these 3, and then once you've tried them, come back and see how you did. So you're going to do sine of 210, cosine of 210, and tangent of 210. So it's all the same angle. You're just doing the 3 ratios for that one angle. All right, so if we sketch this out, 210 degrees, that's in quadrant 3. And it's somewhere like that. Again, not too fussed about the drawing. So our reference angle is this one right here, which is going to be 210 minus 180. So that's 30 degrees. So that's our reference angle. Our ASTC thing, we can think about that now, we're in quadrant 3. So in quadrant 3, tangent should be positive, but nothing else should be. So if we put this all together, so sine of 30, so sine of our reference angle, is 1 over 2. Just get that from your special triangle. Cosine of 30 is root 3 over 2. And tangent of 30 is 1 over root 3. But I didn't ask for 30, I asked for 210. So if we put this together with our ASTC stuff, sine is negative in quadrant 3. So our sine ratio of 210 is negative 1 over 2. Our cosine ratio should also be negative. And so cosine of 210 is negative root 3 over 2. But our tangent ratio should be positive, so it's just going to stay as 1 over root 3. And so that's combining together reference angles, ASTC, special triangles. It's a whole bunch of stuff kind of mushed together. In this chapter, when you see the words exact values, there's kind of two ways you can go. It's either going to be the X, Y, and R stuff with the coordinates from the 2.2.1 video, or it's going to be exact value stuff with the special triangles. So to kind of know the difference, look for key numbers, right? So anything that's 30 or 60 or has a reference angle of 30 or 60 or 45, or anything that uses 1, 2, root 3, root 2, those kind of numbers, that's probably going to be a special triangle question. But if you see any other sort of numbers, if you see, say, like a root 10 or a root 5, if you see any other angle, which you probably wouldn't, that's going to be an X, Y, R question with the coordinate stuff. So let's try another question. So if cosine of theta is -1 over root 2, what is theta? So you could put this into a calculator, but there's a good chance if you're doing this unit with me, you're not going to be allowed a calculator for these sorts of things. And you definitely need to show your work. So how can we do this without using a calculator? How can we do it using exact value stuff? Well, the first thing we want to do is just completely ignore the negative part and just figure out what our reference angle is. And we're just going to do that using special triangles. And so again, we're just going to ignore the negative part. Because remember, reference angles, always positive, always have positive ratios. So if we can just completely forget about that negative for a second, we can get theta r. So cosine of theta r is +1 over root 2. And this is just something we did in the last video. So if you know your ratio, you're going to look at the appropriate special triangle, which in this case is the 1, 1, root 2 triangle. And so the angle that has a reference angle of, has a ratio of 1 over root 2 is just 45 degrees. So that's my reference angle. Step 2 is decide which quadrant you're in. So you might be in one quadrant, you might be in two, it depends on what kind of information you're given. So in this case, we're told that cosine of theta is -1 over root 2. The 1 over root 2 is not super important for this particular part of the question. What is important is the fact that our cosine ratio is negative. So if we bring in that ASTC stuff, cosine is negative in two places, quadrant 2 or quadrant 3. So that means we have an angle in 2 or 3. So we have to actually give two separate answers here. So our last thing to do is we're going to figure out what the angles are. So figure out theta using theta r. So we've got an angle in quadrants 2 and 3 that has a reference angle of 45 degrees. So if we put all of that together, we draw ourselves a quick little sketch. Sketch not necessary, just again, always helpful. So our angle, or angles, because we've got two of them, would look either like this or like this, where they've got reference angles of 45. And so what we want to do is just figure out what those are. So our first option for theta, theta 1, in quadrant 2, that's going to be 180 minus 45, right? So you're using your reference angle, you're going from 180 backwards, and you're going to land at 135 degrees. Our second option in quadrant 2, we're starting at 180, and we're going forwards 45, so that's going to be 180 plus 45, which is going to get us our second value at 225 degrees. It's your turn now. So try doing the same thing here. I'm actually going to give you a little bit more information, which is going to seem like it makes the question harder, but actually is going to make it easier. So I'm telling you that sine theta is 1 over 2. And I'm also telling you that theta is in between 90 and 270. So you're going to have to think for a second about what that means. And then once you're ready, go through the question and see if you can figure out what your angle or angles are. Okay, so again, we need to figure out what our reference angle is. So sine of theta r is going to be, well, it's already positive, but it's going to stay positive, 1 over 2. Then we look at our special triangle. So 30 and 60, because this has a 1 and a 2 in it. This is the 30, 60, 90 triangle. So we've got 1, 2, and root 3. Remember, sine is opposite over hypotenuse, so we want our opposite to be 1, which means we want 30 degrees. So our reference angle is 30 degrees. Now we got to think ASTC, which quadrants are we in? So if I'm telling you that sine is positive, because that was given in the question, right? So sine is positive, because we have positive 1 over 2 here. That means you can be in either quadrants 1 or 2, right? So we've got ASTC. Sine is positive in these two places. But you were also told this thing, 90 is less than theta, which is less than 270. So that's me telling you that your angle has to be between 90 and 270, which puts you in one of these two quadrants. So the only quadrant that works is quadrant 2. So we actually don't have to give two answers here. We only have to give one. So if we sketch that out really roughly, our angle is going to look something like this, where our reference angle is 30 degrees. And so we're going to do theta is 180 minus 30, right? Because we're going backwards. And so our angle is 150. And so there you have it. That is it for section 2.2. That's it for the first half of the unit. So the back half of the unit isn't going to use any special triangles. It's very barely going to touch on reference angles. We're not going to be drawing in standard position. There's no ASTC really. So it's not really connected to this much at all. Before we get to that, one last quick thing, something you will run into sometimes, not so much important in this course, but more so in Pre-Calc 12. You might be asked, well, what's the sine ratio of 90 degrees, or say 180 or 270? So the ones on the axes are a little bit different, and I'm not really going to focus on them too much in this course, so if you're with me, just don't worry about it. But what I will say is basically imagine your angle was like this, and it's getting closer and closer to the axis. And so what's happening as you get closer and closer? Well, if you're making your triangle, think about your x, your y, and your r. As this triangle gets closer and closer and closer, once you hit the axis, your x value becomes 0, right? So if we're here, x is 0, y is whatever it was. So let's just say this point was at 0, 2. So y is 2, and then r, which is the square root of x squared plus y squared, just becomes the square root of, well, 0 plus 4, which is just 2. So our y value and our r value are the same. And so if you go through and you do your sine, your cosine, and your tangent stuff, so sine of theta is y over r, right? Well, that's going to be 2 over 2, which is 1. Cosine of theta is x over r, which is going to be 0 over 2, which is just 0. And then tangent theta gets a little bit weird. So that's going to be y over x, which is going to be 2 over 0, but we can't divide by 0, so that's undefined. And so 0, 90, 180, 270, 360, they're all going to have different values of either 0, 1, or undefined, depending on what you're doing. You're going to spend a ton of time on this in Pre-Calc 12, so just know that it's a thing, but don't worry about it for this course. So now that you're done with this, you are ready to move on to section 2.3 and 2.4, where you're going to learn about the sine law and the cosine law.